Hello, this is Tanishka, and this is my IA application video for 280, and I wanted to go over this problem from the spring 2023 midterm, but I want to review some important topics before we dive in. So to tackle problems like this, we want to know how to do memory diagrams, and we need to understand pointers, references, and arrays before we can do that. So when we have a variable, say for example x, what we're doing is we're storing some data in memory, and here we want to store the integer 2. That's our data, and x is the name for the data in memory, and that's how we can access it throughout our code. A pointer and a reference are simply two other means to access the same data in memory. So when you initialize a pointer, you're basically storing the address. So a pointer is a variable that stores the address of another variable. So when you initialize a pointer, you want to make sure you use this asterisk before the pointer name, and you pass in the address of the variable because that's what you're storing. So for example, x has the address 1000, and this pointer, PTR, will store 1000. But for the sake of our diagram, we usually just show an arrow for intuitivity. And I do want to point that a pointer is a variable on its own, so it will have its own address, and this allows us to do things like double pointers, which is basically a pointer that holds the address of another pointer. Okay, so moving on to references, they're not really a variable on their own. They're kind of just an interchangeable name or an alias to the variable it's referring to. So you can use this ampersand before the name of the reference, and you just assign it to the variable itself, not the address. And in the memory diagram, you can just write the name right next to it because it's not a different entity. It doesn't have an address. It's simply an interchangeable name to use throughout the program. Now, when it comes to using these values, references can be used like a normal variable that you can refer to them directly, just use their name. The only thing you cannot do is you cannot reassign what the reference is referring to. So once it's initialized, it is bound to that variable forever. But for a pointer, you can just call the pointer and reassign it to an address of another variable. And if you want to edit the data that the pointer is pointing to, you must first dereference it, and then you can reassign. All right, another thing we need to know for a memory diagram is arrays and how they work with memory. So rule 1 is an array will always decay into a pointer to its first element, and rule 2, arrays will always be contingent in memory. So what does this mean? If you initialize a bunch of variables, their data in memory can be anywhere. It can be next to each other or far apart, and usually it doesn't matter, but arrays have a special property where all their elements will always be right next to each other. So if this array starts at 200, this will be 204, 208, because each integer is 4 bytes. And because an array will also decay into a pointer's first element, this is how the memory diagram of this array will look. And this is very important because arrays can now utilize pointer arithmetic, which is shown here. It's basically when you add an integer to a pointer, it'll return that many data type spaces after the pointer. Now that's kind of a mouthful, so let's demonstrate that through this example. So here's the integer pointer p, which has the address of x, which is 1000 as we previously decided. So p plus 5 will actually be 1000, which is address that p holds, plus 5 integer spaces. So that is 5 plus 4, or 5 times 4, which will return 1020. That's not very useful because this can lead to undefined behavior. We don't know what's at that memory address. However, with arrays, when you do array plus 2, arrays will have the address of 200 plus 2, and then integer is 4 bytes, which will return the address 208, which is actually the address of the last element. Let's use everything we learned to draw a memory diagram to answer this question. So first I'm going to start off with a memory diagram of this array right here, and then it decays to the first element, just like that. Then we have array plus 2, so that would be right here, and we're just trying to dereference it, so we return 0. Okay. Then we have a new pointer, PTR, that's being assigned to array plus 1, so that will be right here. And then we're taking PTR, and we're reassigning it to the address of PTR plus the value at PTR, which is 2, which would just be right here, and we're just reassigning it. And then we're just dereferencing that value, so that will actually return 3. Now, we have a double pointer, so first let's start by initializing it. And a double pointer holds the address of another pointer, and in this case, that is PTR, so we are just pointing right there. Now, this is pretty loaded, so let's break it down. So when you dereference PTR, you actually will just get PTR. And this is because when you dereference, it just takes you to what the address the pointer is holding. And in this case, PTR is holding PTR. When you double dereference PTR, if you notice, this section right here is the same thing as up here. So you can just say we're dereferencing PTR. And dereferencing PTR is the value 3. So this entire line is saying so dereference PTR will just be PTR, which will equal to PTR minus double dereference PTR, which is 3. So we're moving PTR 3 spaces down, so erase that, and we move it back down to here. And actually all that doesn't matter because the last cout is actually asking us the difference between dereference PTR and PTR. So dereference PTR, as we found out, is just PTR minus PTR, which will always be 0 because they're pointing to the same thing. So this will also return 0.